Okay, so next we're going to be working on parallel lines cut by a transversal, and you will sometimes see them as just a pair of lines or a trio of lines cut by a transversal or two, or sometimes they take place, the facts about these take place within parallelograms as well. So you first need to remember the several things about parallel lines cut by a transversal. We have alternate interior angles, and those are the ones that form the Z, and those measures are equal. Alternate exterior angles, like angles 1 and 2, those are also equal. Corresponding angles state that the measures are equal again, and the corresponding angles are the ones that appear in the letter F. So if you look down here at the bottom, you can see how the letter F is formed, and those angles that form that letter F are congruent as well. And then we have same side interior angles, and this tutorial calls it a little bit different, but we've been calling them same side interior angles, and in that you can see that angle 1 and angle 2 are congruent, angle 3 and angle 4 are congruent. They are on the same side inside the two parallel lines. Because I didn't state this, but the same side interior angles, those are supplementary. Then we have angles forming a linear pair, and that means that they are supplementary. Oh, in fact, let me go, as are the linear pairs. So like angle 1 and 2, they form together, they mesh together on a line. Angle 6 and 5 here are on a line as well. That's a linear pair. Vertical angles are the ones that are opposite each other in an X, and they are equal. So that's a lot of different information about the types of angles that are formed when two parallel lines are cut by a transversal. And moving into our sample question, which I believe is one that we did in class, there's several ways that you can figure this out. So I'm just going to enlarge it a little bit. You just kind of want to be filling in what you know, and then hopefully at some point you'll be able to figure some things out. But basically, I know that the angle right in here is going to be 65, that one, because those are same side interior angles. I have three parallel lines, A, B, and C. So that leaves me with 115 on the opposite side here. So this whole thing is 115, but I'm only looking for part of that thing, so that's going to make it interesting as well. This angle right here is 90 degrees, and this angle here is 28 because these are vertical. This one's 90 because of same side interior. This one here is 90. Oh, and now I have a triangle. And I don't really have a clear plan as to how I'm going to figure this out, but I'm just kind of filling things in based on the things that I know. So I have a triangle, that blue triangle, and I know that 180 minus 90, that right angle that's in there, leaves me with 90, minus the 28 in that other corner leaves me with 62. So this angle here is 62. But remember I said a little while ago that this whole angle here had to be 115, and that's because they form the letter F here. And so if the whole thing has to be 115 and I've used up 62 of it, that's going to leave me with 53 degrees for angle 1. Okay, let's take a look at sample question number 2. We're told that Walker Street and James Avenue are parallel, and so if you want, you can mark your picture. So these two lines are parallel, and then in that case I have two transversals. The transversals are formed by the two brick walls, and so I can get a lot of information about that. Basically I have here some alternate interior angles right here, which makes this angle here 36. And I believe that we're looking for the measure of angle ACB, which is actually between the 36 degrees and the 60 degrees, and all three of those form a linear triplet, not a linear pair, but 36 plus 60 plus whatever that angle is that we're looking for, angle ACB, they all have to add up to 180 because they are adjacent to each other and forming one line. So that'll be 96 plus x equals 180. And subtract 96 from both sides. Oh, those are my babies. And you get 84 degrees. So that center angle is 84 degrees. Alright, so next we're going to work on interior and exterior angles of polygons, and we have the formula that the sum of the interior angles of any polygon is given by 180 times n minus 2. So we should be familiar with that formula. That gives us the sum of the inside angles. So like for a triangle, you know that 180 times 3 minus 2 would be 180 times 1, which gives you 180. So that's just our common one that we know. If you want to know the measure of just one angle of a regular, and remember regular means that it has all the same sides and angles, you just use the sum that you found in the first formula and then divide it by the number of sides. So that's what this formula is. And another fact that we should know is that the sum of the exterior angles of any polygon, doesn't matter what it is 360. And then also on this page I gave you some names of shapes that you should be familiar with. This one here I don't think is wildly important, but the rest I think are probably things that you should know up to dodecagon. And you don't need to know these. These are probably Latin names. We don't need those. Alright, so our first sample question says, a regular hexagon and a regular heptagon share one side as shown in the diagram. So they want to know what is the measure of angle X, the exterior angle there. Well, there's a couple of ways that you could solve this problem. You could figure out how many degrees are in each angle of each of those two, the hexagon and the heptagon. The hexagon has 6 sides, and the heptagon has 7 sides. So if I look at the hexagon, that's going to be 180 times 6 minus 2, 180 times 4, so 720, and then I divide that by the number of sides. That'll give me the measure of each interior angle, and so that's going to be 6 goes into 7, 120 times, so that's 120 degrees. So this right here is 120, and then I'm going to find the one next to it by doing the same thing but using my 7, so that's 180 times 7 minus 2, so 180 times 5. For 900, and then I divide that by 7. So 7 goes into 900. I need a calculator. Okay, so we'll go ahead and say that that's 128.6. So I got 128.6 here. And now I can think about this. There's only one way to solve it, but the whole thing all the way around is going to add up to 360. So 120 plus 128.6 plus x, that exterior one, equals 360. And when I solve, I add those up and subtract them from 360, I get x equals 111.4, so my answer choice is B. Now for sample question number 2, I'm given one interior angle of a regular polygon, and I'm told that the measure of that one interior angle is 140. So I'm going to use that formula that gives me the individual angles. That's the sum divided by the number of sides. I know that my number of sides is equal to 140. So basically all I need to do is solve this equation. I'm going to start by multiplying. I'm going to distribute the 180, so that's 180 n minus 360. That's my numerator. And then I'm also going to, at the same time, multiply both sides by n. And now I'm going to go ahead and solve this equation. So I'm going to subtract 140 from 180, so that's going to give me 40n. And also at the same time I'm going to add 360 to both sides. And now I get, divide both sides by 40, and I get n equal to 9. Now, that's not what they've asked me to do. They've asked me to tell what is the sum in degrees of the measures of the interior angles. So now all I need to do is 180 times 9 minus 2, so that's 180 times 7, which is 1260. And this is my answer.